Hello. Hello. Good morning. Good morning. Can I know your name? Sanju, Chandu. Can I know your name? ಎಲ್ಲ ಕ್ಲಾಸ್ 10 ವಿದ್ಯಾರ್ಥಿಗಳು PUC2 ವಿದ್ಯಾರ್ಥಿಗಳು ನಮಸ್ಕಾರ ಸ್ಥಿತಿಗೆ ಬನ್ನಿ. ಇಷ್ಟ ದೇವತೆಗೆ ಗುರು ಹಿರಿಯರಿಗೆ ಪ್ರಾರ್ಥನೆಯನ್ನು ಸಲ್ಲಿಸಿ ಇಂದಿನ ಎಲ್ಲ ಅಭ್ಯಾಸಗಳನ್ನು ಏಕಾಗ್ರಚಿತ್ತದಿಂದ ಶಾಂತ ಮನಸ್ಸಿನಿಂದ ಮಾಡಿ ಮುಗಿಸುವ ಶಕ್ತಿಯನ್ನು ಕೊಡಲು, ಕಲಿತ ವಿಷಯಗಳನ್ನು ಜ್ಞಾಪಕದಲ್ಲಿಟ್ಟುಕೊಳ್ಳುವ ಶಕ್ತಿಯನ್ನು ಕೊಡಲು, ಜ್ಞಾಪಕದಲ್ಲಿರುವ ವಿಷಯಗಳನ್ನು ಪರೀಕ್ಷೆಯಲ್ಲಿ ಸರಿಯಾಗಿ ಬರೆಯುವ ಬುದ್ಧಿಶಕ್ತಿಯನ್ನು ಕೊಡಲು, ಜ್ಞಾಪಕದಲ್ಲಿರುವ ವಿಷಯಗಳನ್ನು ಪರೀಕ್ಷೆಯಲ್ಲಿ ಸರಿಯಾಗಿ ಬರೆಯುವ ಬುದ್ಧಿಶಕ್ತಿಯನ್ನು ಕೊಡಲು ಇಷ್ಟ ದೇವತೆಗೆ ಗುರು ಹಿರಿಯರಿಗೆ ಪ್ರಾರ್ಥನೆ ಸಲ್ಲಿಸಿ ಟೇಕ್ ಡೀಪ್ ಬ್ರೆತ್ಸ್. Yes, good morning, my dear students. In the last class, we are studying problems on concentration of solution. I think I am left with fifth problem from the calculate the molality. You are asked to calculate. Look at the problems. How to solve problems on molality. When percentage is given, we'll see today. Molarity, C, mole fraction of potassium iodide if the density mass by mass, aqueous potassium hydroxide, if the density of 20% mass by mass of potassium iodide is 1.202 grams per mole per liter. Grams per liter. Look at here. Gram per cc. Grams per milliliter is the question. See, let us try to understand how to face this particular problem. You are asked to calculate molality, mole fraction, all the three of them. First of all, you must know what is the formula of molality, small m, is given by. See, first of all, you recall the formula you are going to use and the requirement from the data. Molality formula is the number of moles divided by mass of solvent in kg. Okay. Second one is molarity, capital M, is given by number of moles of the solute divided by volume of solution in liter. Remember the formula. And what else is asked? Mole fraction of, there are two components. Mole fraction of potassium iodide is given by number of moles of potassium iodide divided by mass of solvent. What is the solvent here? They have said that it is aqueous solution. What do you mean by aqueous solution? mole fraction of 20% by mass of aqueous potassium hydroxide. They have given aqueous potassium hydroxide. Whenever aqueous is there, solvent is mass of water. You have to take. First of all, you must know the formula correctly. And according to the formula, you must go on collecting these informations, then you can find it. First, then you take the given. What is the data given? First, they are given is the concentration of potassium iodide. The concentration of potassium iodide, we write generally in square bracket, like 20% by mass. 20% mass by mass. What is the meaning of it? That is mass of water, mass of potassium iodide will be 20 grams. Then mass of solvent. What is the solvent here? Water. Mass of water is 80 grams. Okay. First of all, we have to calculate molality. So, to get molality, what is required to you? You must take the number of moles of the solute. Number of moles of the, what is the solute here? Here solute is potassium iodide. Solvent is water. Carefully study the formula and the requirement to get the molarity and mole fraction of potassium iodide. Mole fraction of potassium iodide is given by number of moles of potassium iodide, number of moles of potassium iodide plus number of moles of water, because mole fraction is given by number of moles of the component divided by some total number of moles of the component in the solution. These three formulas you should keep it in our mind. And first let us see the molality. To get molality, in the numerator we want number of moles of the solute. What is the solute here? Potassium iodide. What is the formula to get the number of moles of potassium iodide? That is mass upon molecular weight. Out of 100 grams, what is the mass of potassium iodide? Is 20 grams. Okay. Molecular weight of potassium iodide. Potassium is 19. Atomic weight is 19. And that of iodine will be 127. Approximately. 9 plus 7 is 16, carry 1. Then 2 plus 1, 3 plus 1 is 4. You get 146 grams. Potassium atomic mass of potassium. Atomic mass of potassium you take 39. Or even you can take 40 also, plus 127. Atomic number of potassium is 19. Add them. 9 plus 7 is 16, carry 1. 3 plus 3 is 6. Then 166 is the atomic weight of it. Now you calculate the ratio, number of moles. Yes, you can continue. 166 grams. What is 20 upon 166 will be? Calculate. 20 upon 166. You can use simple calculator. 2 divided by 166. It will be 0.120. You can take 0.120 is the mole, is the number of moles. Now, is the ground ready to get molality? Yes. The first question asked is molality. You have the formula already. Number of moles of the solute, we got it as number of moles of the solute is 0.120. Number of moles is 0.120 divided by. What is the mass of the solvent? Mass of the solvent in kg. Now it is 80 gram. 80 gram. You can get in kg. To get in kg, divide it by 1000. Then you get in kg, 0 cancels. You can take it at 0.08. If there are 2 zeros, you shift the decimal point 2 places to the left. You got now 0.08. Now you take the ratio of it. That is 0.120 approximately. We can get 0.120 divided by 0.08. It will be, molality will be 1.5 molal. Or simply you can write M. It is 1.5 molar. Or mole per kg. Any doubts here? Any doubts here? Okay. Second question. Second question. Molarity. What is molarity of the solution? That is, molarity is given by number of moles upon volume of the solution in liters. They are asking. Okay. Now the question is volume of the solution in liter. For that you are given with the density. What is the meaning of density? 1.202 gram of the solute is present in 1 liter of the solution. That is the density. 1 cc means 1 cc of solution. 1 cc of solution contains how many grams? 1.202 grams. Means density is given by mass divided by volume of solution. Density is given by mass divided by volume of the solution. Now, how can we get volume of the solution? Because we want volume of the solution in liters. For that, you have to take what? This 1.208 gram mass is already given to you, right? Now, you are given with the density. Density is given to you. Now, to get the volume, you take volume to the left, density to the right, right? To get molality, we want a number of moles of the solute already ready. What is the number of moles of the solute? Number of moles of the solute is 1.120. Number of moles of the solute to get molality. Numerator is ready. 0.120. But you have to get the volume of the solution in liter. Is that clear to you? Density is given, then volume of the solution in liter. How much? What is the number of moles of the solute? Number of moles of the solute is given by mass divided by molecular mass. Okay. Mass of the, we can get the mass of the potassium iodide divided by molecular weight of the potassium iodide. You will get the mass of the potassium iodide is given already that it is 20 grams. Okay. What is the density? To get the volume of the solution, density is given by mass divided by volume. If you take volume to the left, you get mass upon density. So, mass in grams of potassium iodide is 20 grams. Then you get volume of the solution, 20 grams. Divided by density is given as 1. What is the density? 1.202 gram per cc. 1.202. 20 grams, 1.202. Divide it 20 upon 20 divided by 1.202 will give you 20 divided by 1.202 give you 16.64. You can take, round it off, 64 you can take. These many cc, but you have to convert it in volume of the solution in liter. Clear it? Volume of the solution in liter, to get it, you have to multiply it with 1000 or divide cc. Cc it should be converted into liter because 1 liter is equal to 1000 cc. Therefore, to convert it into liter, conversion factor is 1000 divided by 1000, you will get 0.01664 liter. So this particular volume will contain what? Volume of the solution. You got 0.01664. You can write now, substitute the values. You got already. You are asked to get molality you got. Molarity you get. Volume of the solution. Total mass of the solution. You are taking total mass of the solution. Total mass of the solution divided by density, because volume of the solution, if you need, you have to take the mass of the solution. Total mass of the solution 20 plus 80 is 100. You will get, I think, 100 upon mass of solution. Because to get volume of the solution, you have to take mass of the solution, not only solute. 100 upon 100 divided by 1.202. 83.1946 cc. Convert it into liter. For that, you have to divide it by 83.194 divided by 1000. You will get now, shift 3 decimal places to the left, 0.08319. You can take it approximately liter. Now you can substitute the values to get molality. It's very easy. So what is number of moles of the potassium iodide? 1.120. Total volume of the solution will be 0.08319. Now you divide and get the value, close value, 0.120 divided by 0.08319. You will get the answer as 1.442 molar. Approximately 1.442. I hope you understood the point. So to get the molarity, you need a number of moles of the solute. What is the number of moles of the potassium iodide we calculated? Is 0.120 mole. You wrote it in the numerator. Then you have to find out volume of the solution in liter given density. When density is given, it is density is given, it is mass divided by volume. Then volume of the solution will be equal to it is mass of the solution divided by molecular weight. Mass of the solution upon density of the solution. So density of the solution is given, substitute the value of density, and we got it as 1.202 given, 83.1946. Mass of the solution will be 100 grams, totally percentage. So mass of the solute is 20, solvent is 80, 80 plus 20 will be, you have to take solution, mass of the solution. 100 divided by 1.202 gives many cc, convert it to liter, and now you can calculate number of moles upon volume of the solution in liter. You will get 1.442 m. Take the third part of it. Third part of it is mole fraction. I will rub this part. Let us calculate mole fraction. To get the mole fraction, you need a number of moles of both. Which one? What is the formula to calculate mole fraction? Mole fraction of chi of potassium iodide is given by chi of potassium iodide, number of moles of potassium iodide divided by number of moles of potassium iodide plus number of moles of water. What is the number of moles of potassium iodide? Number of moles of potassium iodide, just now we calculated, I I think it is mass of the potassium iodide is 20. Number of moles of potassium iodide just now calculated. Mass of the iodine is 20 divided by molecular weight of the potassium iodide. Just now you got it as potassium is 39 plus 127. You are getting 20 upon, it is 140, 16, carry 1. Just now you got it. 9 plus 7, 16, carry 1. 2 plus 1 is 3. 3 plus 1 is 4. Molecular weight, sorry. 127 plus 39. 9 plus 7 is 16, carry 1. 5. I think it is 20 divided by molecular weight. 16, carry 1. 4 plus 2, 6. It is 166. And just now you did it. Again, I am showing you. 20 divided by 166 gives you 0.120. Just now you got. Now to get the number of moles of water, what is the mass of water taken here? 80 grams. Divided by molecular weight of water is 18. 18 ones are 18 fives are. Sorry. 80 by 18. 80 divided by 18 gives you 4.444. 4.444. Now you can calculate mole fraction of potassium iodide easily. Taking the number of moles of potassium iodide is 0.120 divided by, take number of moles of potassium iodide is 0.120 plus 4.444. You can get the close answer. 0.120 divided by 4 plus 0 is 4. 4 plus 2 is 6. 4 plus 1 is 5. You get to 4.564. Right? You can divide it. 0.120 divided by 4.564. Answer will be 0.02629 mole. That is the mole fraction. Mole fraction will have no units. As the number of moles cancels, you will get 0.02629. So that's all the problem, my dear students. I hope you got it. First you write the formula, then you prepare the requirement to calculate number of moles of the solute. So like this, one by one you details you calculate. Percentage means in that 20 gram will be potassium iodide, remaining 80 gram will be water. Right? So that is the solution of this problem. We'll see some end text questions. They are not very easy. Therefore, I am taking one extra session for calculation. Many students neglect this area. Directly, if you go to solve the competitive exam questions, you will not have the in-depth understanding of the problem. See, in the exercise NCERT, problem number 1.4, if you have textbook, you can open it. The problem is concentrated nitric acid, concentrated HNO3 nitric acid used in the laboratory, used in the laboratory, in the lab. In the lab work is 68% nitric acid. This is called as commercial nitric acid. By mass in aqueous solution. By mass, look at the details. In aqueous solution, study the question. I will give analysis of it, aqueous solution. Slowly understand it. Solution. What should be the molarity? What should be the molarity? What should be the molarity of such a sample, of the acid, similar type of the problem of the acid. If the density of the solution is 1.504 gram per milliliter, similar type of the problem. Take some 2-3 minutes to try to solve the problem. Kipti, good morning. Where is your friend? Solve now. You invite your friends from the school, college to join. See, many students face a difficulty in solving competitive exam questions because they directly go to try to solve the competitive exam problems without actually completing the NCERT text. You solve it. See, the hint I will give you. You take some 5 minutes and solve. First of all, collect the data. Metric, what we are asked to get, what is asked, you collect it first. Then you can prepare. What is asked? Molarity. What is the formula of molarity? Molarity is equal to number of moles of the solute, carefully note down, divided by volume of solvent alla. Solution adu edrolaga liter dolaga ಕಂಡು ಹಿಡಿಬೇಕು. ಆಯ್ತು. ಹಂಗಾರೆ ನಮಗೆ ನಂಬರ್ ಆಫ್ ಮೋಲ್ಸ್ ಆಫ್ ದ ಸಲ್ಯೂಟ್ ಯಾವ್ದಿಲ್ಲ? ವಾಟ್ ಇಸ್ ದ ಸಲ್ಯೂಟ್? ಸಲ್ಯೂಟ್ ಈಸ್ 68% ನೈಟ್ರಿಕ್ ಆಸಿಡ್ ಗಿವನ್. ಇದ್ರ ಮೀನಿಂಗ್ ಏನು? 68% ನೈಟ್ರಿಕ್ ಆಸಿಡ್ ಇದ ಮೀನಿಂಗ್ ಏನಪ್ಪಾ ಅಂತಂದ್ರೆ 100 ಗ್ರಾಮ್ ನೀವು ತಗೊಂಡ್ರಿ ಅಂದ್ರೆ ಅದ್ರೊಳಗೆ 68 ಗ್ರಾಮ್ ನೈಟ್ರಿಕ್ ಆಸಿಡ್ ಇರ್ತದ. ಉಳಿದದ್ದು ಅಂದ್ರೆ ಮಾಸ್ ಆಫ್ HNO3 is equal to how much? 68 grams. ಹಂಗಾರೆ ಮಾಸ್ ಆಫ್ ವಾಟರ್ ಎಷ್ಟು ಇರ್ತದ? ರಿಮೈನಿಂಗ್ ಮಾಸ್ ವಿಲ್ ಬಿ ಮಾಸ್ ಆಫ್ ವಾಟರ್ 100 minus 68. 100 minus 68, it will be 32 grams. Okay, we will keep it ready. Mass of the nitric acid you got. First you want to get a numerator. Have like this. First you clear the numerator. Number of moles of HNO3. To get number of moles of HNO3, the formula is mass of HNO3 upon molecular weight. You have to calculate molecular weight of HNO3. How can you get molecular weight of HNO3? Hydrogen 1, they have not given. Nitrogen 14 plus 3 atoms of oxygen, 3 into 16. You get 15 plus 16 3s are 48. Add them, 58, 63 grams. Okay, 63 grams. Now you calculate number of moles. What is the mass of the nitric acid given to you? 68. Divided by molecular weight of it is 63. Divide 68 by 63, you will get number of moles of the nitric acid. Easy question, but you have to practice it. 68 upon 63. You will get, you can use calculator, 1.079. 1.079 up to 3 decimal places, sufficient. And the numerator problem is solved now, right? Then what is your aim now? You have to get the volume of the solution in liter. No volume, any information is not given except density. This is going to help you. What is the density is given by mass divided by, yes sir, volume. Means the density of the solution is mass of the solvent divided by volume of solution. You cross multiply it. Take volume of the solution here because we are interested in volume of the solution divided by mass of the solvent divided by density. What is the mass of the solvent? Sorry, mass of the solute. I'm sorry. Mass of the solute. Because you are given with the density of nitric acid in a gram per cc, which is mass of the solute is how much here? 68 grams divided by, it is milliliter. Milliliter means it is given in cc, that is 1.504. No problem. Only you have to calculate 68 divided by 1.504. Calculator hachri bartad nimga. Volume is 45 point. You can take up to 2 decimal places. I will take 213. Round it off to 3 using calculator. These many cc's you will get. Then volume of the solution in a liter we want. In a liter means you have to divide it by 1000, that is 45.213 divided by 1000 liter. 1000 cc means 1 liter. 45.213 conversion factor is divided by 1000, you will get 0.0. How many zeros? 3 places. 0.45213 liter. Or you can take just 3 decimal places. 0.452 liter. They will check your answer up to 3 decimal places. Now the problem is almost completed. Volume you got. What is the molarity formula? Molarity's formula is the number of moles of the solute. Already here, solute. What is the number of the moles of the solute you calculated? Number of moles of the nitric acid is 1.079. Here it is. Number of moles of the solute we already calculated. Divided by volume of the solution in liter. It is ready here, which is 0.0452. Just divide it, you will get the molarity. 1.079 divided by 0.0452. You get 23.871 molar. Generally it is called as molar. Molality is called as molal. Just replace R by L. So that is the answer. Check for any mistakes. Clarify your doubts. Volume of the solution in liter, you check it again. Volume of the solution in liter. Volume of the solution. Okay, sorry, again. You have to take density is equal to number of solution. Sorry, mass of solution you have to take. Instead of 68, you have to take solution 100. Here there is a small mistake. You correct it. 100 upon 1.534. Volume in liter, mass of the solution you have to take in case of molarity. That is a mistake. 100 divided by 1.504. You can get 150.4. 150.4 divided by density is given as density. What is the density given to you? 1.504. 1.504. Now you can get the volume in cc. That is, you have to take 100, not solute, because volume of solution is equal to mass of the solution upon density. Total mass of the solution is 100 grams. Therefore, I took only 68. That was the mistake. Correct it. 100 divided by 1.504. It comes out to be 66.489. 66.489. Now you get all of the solution in liter as 0.06649. You can take 0.06649. Now you can substitute that value. That is molality is given by 1.079 divided by volume of the solution liter will be 0.0. Now it becomes 6649. Don't take only mass of the solvent. You take the mass of the solution because this density is for the mass of the solution. you will get 1.079 divided by 0.06649. Check your answer, it will be correct. 16.22 molal. That is the answer. Verify your answer. This was 228 and you can round it off to get the answer. When there is 8 greater than 5, you can add one digit to the previous digit. Therefore, this is called as approximation. You studied in the first year. You will get 1.16.23 molar. Clarify your doubts. Interact, please. Don't keep quiet. Next problem. There are 3 or 4 more problems. Just how many problems are possible today I will solve. Remaining you try. Otherwise you ask me doubts. Next period we will continue with the solubility. Theory part of it. Theory part is very easy. According to me, in this chapter, any difficult area is there. These conversions and numericals on it, this first part is difficult. So remaining part, vapor pressure and elevation in boiling point, depression in fusion, those problems will be very easy. You can comfortably solve. But these conversions of the units of the concentration, molality, so these are the dangerous area. Therefore, I am focusing on this particular area. See, next problem, 1.5 in your text. A solution of glucose in water is labeled as. Carefully study the problem. A solution of glucose. A solution of glucose is labeled as. Is labeled as 10%. Carefully note down. W bar W means mass percentage. What would be the molality? What would be the molality? What would be the molality and mole fraction? This area, according to me, is not easy area. This you practice more. In this area, mole fraction. What would be the molality and mole fraction of each component? Of each component in the solution. Of each component in the solution. If the density of the solution, again similar type of the problem. If the density of the solution, carefully read the word solution. Therefore, you must not take the solvent. Solution is 1.2 gram per milliliter. Then what shall be molarity of the solution? See, what shall be, make this area perfect. What shall be molarity of the solution? Molarity of the solution. Okay. Again, similar type of the problem. Good question for 3 marks. See, you have to find out the 3 values. First of all, you study carefully the problem. Read word by word what is given to you. A solution of glucose is labeled as a 10% W bar W. Means what? Mass of glucose is equal to, you collect the information, mass of glucose, whatever information is possible, you collect them. Mass of the glucose, you know the formula of glucose is C6H12O6 is 10 gram. Then what will be mass of water in it? Total percentage means you are taking for 100. Water H2O is 100 grams. So number of moles you have to calculate, we will finish that area. See, for that you need molecular weight of glucose. Calculate. Molecular weight of glucose C6H12. There are 6 carbon atoms. Atomic weight of carbon is 12. 12 into 6 plus 1 into 12 plus 6 plus 6 into 18. I think you get 180. Remember it. I am showing you. 12 6 are 72 plus 12 1s are 12. 18 5 are 90, 108. You can calculate now. 8 plus 2 10, 10, 10. 18. What is the atomic weight of, 16 6 are. Atomic weight of oxygen is 16 6 are 96. 6 plus 2 8, 8 plus 2 10, carry 1. 9 plus 1 10, 10 plus 1 11, 11 plus 7 is 180 grams. Then similarly, molecular weight of water, you calculate basic things. Molecular weight of water, you know it is 18 grams because oxygen 16 plus 2 18. So number of moles of water, first glucose you find out, number of moles of glucose, mass of glucose upon molecular weight of glucose. What is the mass of the glucose? Mass of the glucose is 10 grams. Molecular weight of glucose is 180. You will get number of moles of glucose as, you just divide 1 by 18. 1 divided by 18. Your answer will be 0.055 recurring. You can take 0.056 up to 3 decimal places. Number of moles of water will be, what is the mass of water in it? 90 grams. Molecular weight is 18. 18 ones are 18 5s are 90. Therefore, you get 5 moles. This is 0.056 mole. 1 by 80. Correct. Now you go for solution. Case 1, what you are asked. Mole fraction of each component in the solution. If the density is also given, what is the density is given? 1.2 gram per milliliter of the solution. Density of the solution. Okay, no problem. First, what you are asked to calculate? You have to note down what is asked. Very important. After noting down what is given, what is asked, you are asked to get what? First one, what you are asked? What would be the molality? Small m. Second part is asked is molality and mole fraction of glucose, molality of glucose solution. Third one is molarity. All the three are asked. First of all, we'll start with the molality. What is the formula of molality? Formula of molality is given by number of moles of the solute, isn't it? And mass of solvent. Am I correct? In kg. Mass of the solvent in kg. What is the mass of the solvent here? Mass of the solvent is water. When it is 10 grams, water will be 90 grams because percentage. When the mass of glucose is 10 gram, mass of water will be 100 minus 10, which is 90 grams. 90 grams mass. Now, number of moles of the solute, you already prepared it, ready here. But what you need? Mass of the solvent in kg. Kg means you shift decimal point through 3 places to the left, you get 0.090 kg. 0.090 kg. Now you can easily calculate molality. Number of moles of the solute is 0.056 divided by mass of solvent in kg. What is the mass of the solvent? Water 90 gram. In kg it is 0.090. Divide it. You will get the answer. That is 0.056 divided by 0.090. You will get 0. Number of molality is equal to 0.622 molal. Check your answer. First part is completed. Then you are asked to get molarity, the mole fraction of glucose. Very easy. Already you have prepared. I hope you understood this one. If you have got any doubts, you can. Got it? Okay. Next, you just interact. If you get any doubts, you can stop me and clarify the details. Second part you are asked is mole fraction of glucose is given by number of moles of glucose G divided by total number of moles of glucose plus number of moles of water. Already we have prepared it. Mole fraction of glucose is given by number of moles of glucose is 0.056 divided by 0.056 plus 5. You can easily get the number of mole fraction. It is chi, not x. Will be 0.056 divided by 5.056. 5 is whole number. Just divide it, you will get the mole fraction. Very easy. Don't worry about numbers. Whatever numbers may be, you can calculate. 0.056 divided by 5.056. You will get 0.0110 is there. You can take it as 1 m. Sorry, small m. Molal. It should be read as MOLAL. 0.0111. No, it's a fraction, no unit. Sorry, no unit. Mole fraction is 0.11. Let me rub this question part so that I can calculate the third one. All details are ready now. But many students do mistakes while getting molarity. See molarity formula carefully. Number of moles of solute already ready, that of glucose, divided by volume of the solution in kg. See the difference between molality. In molality you are taking mass of the solvent in kg. In molarity you are taking volume of the solution in kg. Already numerator is available. What is the value? Got it already. 0.056. We have to fill in this gap. Volume of the solution in kg. Given density. Third time I am showing you. So density of the solution is given. Read the question. Already you collected, I rubbed it. What is the density of the solution? So density of the solution is 1.2 gram per ml. You know the density formula is given by, density of the solution is given by, that is mass of solution, very important, divided by volume of solution. Density of solution is, you can write, take volume of the solution to the left, then you get the total mass of the solution. Mass of solution, not the solvent or solute, eradu kude 100 over upon volume of the solution upon density of the solution, you have to write. Now you can easily get the values, right? What is the mass of the solution is 100 divided by density of the solution is 1.2. Just divide 100 upon 1.2. You can get the answer. 100 divided by 1.2. 1.2, you will get the answer 83.33 milliliter. Milliliter means cc, centimeter cube. But we want it in a liter. Okay, let me rub this part. We are in the last part anyhow. We want it liter. To convert it into liter, divide by 100. 83.33 divided by, that is 0.0833 liter. You can take. Now you substitute the, fill in the blanks. What is the volume of the solution? Volume of the solution in kg molarity in a liter. That is, molarity is equal to number of moles of the solute upon volume of the solution in liter. Volume of the solution in liter, we got it as 0.0833. Just divide it, you will get the answer. What is the answer? 0.0 divide using calculator, simple calculator, 0.056 divided by 0.0833, you will get 0.672 molar is the answer. Thus, we got all the three, that is molarity and mole fraction. I hope you understood them, right? I will take another little bit difficult question, 1.6. Any doubts in this? You can ask me doubts. Ask me doubts. Okay? Fine. We'll continue with the next problem. I hope you understood this one. If you are not understood, you just rewind it again. You can understand it better. Next, 1.6 in the textbook. How many ml of, carefully solve very dangerous question. How many ml of means cc, will use cc of 0.1 molar HCl are required, take the problem, study carefully, are required to react completely with, with 1 gram mixture. Tough question. 1 gram mixture of sodium carbonate, Na2CO3, and sodium bicarbonate, NaHCO3, containing equimolar amounts, containing equimolar means number of moles are same, equimolar amounts of both, So whenever you solve difficult problems in physics, chemistry, statement problem in mathematics, first of all you have to collect the data given. What you are given with? The concentration of HCl is given, molar concentration of HCl, we write it in a square bracket like this, which is 0.1 m. What is the meaning of it? Means 0.1 mole is mole in 1 liter. That is the meaning of it. HCl are required. How many cc? That is the question. We will think of it. React completely with 1 gram of mixture. There are two compounds, sodium carbonate, better mass of sodium carbonate, mass of Na2CO3 plus mass of NaHCO3. Total mixture is 1 gram. See the interesting thing. And the number of moles of both of them are same. Number of moles of Na2CO3 equimolar. See the word. What is equimolar? Number of moles will be same. Number of moles of sodium carbonate is equal to number of moles of NaCO3. We don't know. Let us call it as X mole. Both of them are X mole. Equal. We don't know X. We have to find it out. Now, what is our aim? How many ml of 0.1 m HCl is required? For that, you have to see the reaction. Whenever carbonates and bicarbonates are treated with HCl, you must know to write the reaction, stoichiometry. See, whenever sodium bicarbonate reacts with HCl, write the reaction. Reaction you write, you will understand lot of things. HCl. Can you guess the product here? You can get the product as NaCl, Cl plus S2O. Effervescence are observed in the laboratory. You studied in the 10th standard. Whenever any bicarbonates or carbonates are treated with HCl, what they form? I'll give the hint. Analysis. What it will form? Yes, it will form NaCl and water. Then what happens? So balance equation. Na 1 atom, chlorine 1 atom, carbon 1 atom, oxygen atoms are 3, 2 plus 1, 3, hydrogen atoms. Here is 1, here is 1. No, need not balance it. Means 1 mole of sodium bicarbonate react with 1 mole of HCl. Remember the reaction. We are not worried about products. Similarly, we will take sodium carbonate plus HCl. What is the product? Again, you are getting NaCl plus S2O plus S2O plus CO2. Balance the equation. You can get now Na2 2 NaCl. Write the equation. I will tell you. And if you attempt such problems, your mind will be set to the type of the problem. Then you can attempt the multiple choice questions. Carbon. Then you go for shortcuts. 3, 2 plus 1, 3. Now see here, 1 mole of sodium carbonate always reacts with water. To completely react, you need water. 2 mole of it. I hope you got it now. What is our asked now? We will go for asked. What you are asked, very important question, not an easy question. How many milliliter of, means volume in cc of HCl is required here. Note, to completely react. If both of them contain equimolar amounts of the both. Now how do you solve this? Are you getting me? So it requires a little more discussion. Tomorrow I will, next period I will continue. You try this, right? Because we cannot finish it within 2-3 minutes. Already time is up. So next period we will continue the remaining part of it. You just study it. Along with that, we will finish this particular area by solving 1.6 problem. I am solving. If you solve 1.7, 2 more problems you will solve. Then you study solubility. Next topic, solubility in the next period. And I will start discussing the theory part of it. Understand theory first. Then very important thing is in physical chemistry. This particular solution is from electrochemistry and solution are from physical chemistry. Physical chemistry will have numericals. Inorganic and organic chemistry is very easy. If you study it, you can manage it. If you remember it, sufficient. But here you need lot of applications. See, the textbook problems you solve first. If you are perfect in textbook problems and how to calculate molality, mole fraction, right, without confusion. Now try this one, think about it. I will continue in the next class, right? And QC2 response is very low. Many of you are not coming in a live stream, and particularly I am working in the morning hours for PUC2 students only. Clear it to you, because no other time is left. Evening all schedule is packed in SLC, PUC1, state, CBSE, ICSE. Therefore only option is morning, and therefore you watch it and join the WhatsApp group. You, at least if you like the classes, you bring students. If you come on live and start interacting, like 10 students are interacting wonderfully, ICSE students are interacting wonderfully, PUC1 and PUC students are not serious. Please join your friends, ask them to come to the live stream and let them interact. More you interact, more interest I will get to teach you. That's all, my dear students. We will continue tomorrow, same time, with the mathematics, inverse trigonometric function. This month I have got 3 chapters to cover. 2 chapters in this in detail, solutions and electrochemistry. 2 chapters, 3 chapters in mathematics. One is inverse trigonometric function. First chapter, second chapter, matrices. 3 chapters I am covering this month. Already we are covering ITF, and the monthly chapters will be covered. On that we will have multiple choice question test. We will have appeared questions in Karnataka CET, JEE. Then you can solve once the concepts are clear. I'll go systematically, step by step. That is the only way. Systematic way is the only way of learning. If you jump anything, then you will be put in trouble. Directly you cannot build the third floor. Step by step you will go. First learning should be slow and perfect. Give its own time, take your own time depending upon your capacity and solve. That's all for today, my dear students. Download Vedium's app, practice mind maths. Okay, bye bye, see you.